Hi, welcome back to Leetcode. So in this video, we discuss on the second problem from today's weekly contest 467. The problem name is maximize the sum of at most k distinct elements. So you are given a positive integer array nums and integer k. Choose at most k elements from nums so that their sum is maximized. However, the chosen numbers must be distinct. Return an array containing the chosen number in strictly descending order. So that means, suppose for this example, so first of all, what is the actual condition? Condition is that whatever the number we will choose, so we have to choose at most k numbers. First of all, at most k numbers, okay, and all the numbers is distinct. And another condition, at most choose at most k elements from the nums so that the sum is maximized. Okay, and also we have to maximize the sum. Maximize the sum. Whatever the number we will choose, for that, for those numbers, if we do the sum, so we will try to check the maximize that. Okay, so what is our target? We have to choose the distinct. So suppose we actually have one array, input array. Suppose for this example, 84. Let's take this example. Okay, 84, 93, 100, 77, and next is 90. K is equal to suppose 3. Alright, K is equal to 3. Yes. So first condition is that we have to choose k elements. All are actually distinct, right? And all are actually try to maximize the sum. So what number we should choose to maximize the sum? We have to choose the number which actually largest in the input array. So first of all, we know that our k is 3, so we can choose 3 numbers only from the input array. So what is the maximum number? That is actually 100. Okay, next maximum number is 93. Next maximum number is 90. All right, so this is the k is equal to 3. We have taken 3 elements only from the input array, 100, 93, 90. So first condition is true. Next is this should be, all numbers should be distinct. Yes, 100 is distinct, 93 also distinct, 90 is also distinct. This is also valid. Maximize the sum because we have taken only the maximum number from the input array, right? So this actually we have written in this order: 100, 93, then 90. Clear? Next is, suppose another example. Suppose 1, 1, 1, 2, 2, 2. Suppose k is equal to 4. So that means I can take 4 elements from the input array, right? 1, 1, 1, 2, 2, 2. So we have actually 6 elements in the input array, but we can take 4 elements. Now, so first, what is the largest element present in the input array? 2. Okay. Next, largest element, can I actually take 2? No, because I have already taken 2. Okay. Next, largest number 2. So we can't take this. Okay. Next, largest number is 1. Okay. Next largest number 1, but 1 is already present. Next largest number is 1. So this is already present, so I can't take this. So I have checked all the input array elements, but we can take only these 2 elements. But our k is equal to 4. It's okay. They have told that we can take maximum k elements, maximum. So, but it's okay that if it is less than equal to k, that's okay, right? Maximum k elements I can take, but it here to 2. This is okay. Now, this is actually maximum. What is the sum? 2 plus 1. It is actually 3. Okay, and all are actually distinct. Yes, this condition is valid. And how many numbers we have taken? We have taken 2 elements, and this is less than equal to k. This is also valid, and the sum is also maximized, right? So this is also valid. So we have to return 2, 1. Got it? So how can we solve this? So first of all, whatever the input actually I have, so sort this in descending order. Okay, descending order. So that means suppose here is 10, 9, 9, 8, 7. In this actually I will sort this input array. Now I know that I can take k elements, right? So I'll start from this from left to right, because I know that this is the maximum element is present in the input array, right? So I'll check that can I actually take this not, but to handle this is actually distinct or not. To handle this, I need actually one set. So from this set, I can easily identify that this number is already taken or not, right? So that's why this set is initially empty. Okay, k is equal to now suppose 4. Okay, so I'll try to take 10. What is the condition? Our k is should be greater than 0. That means I can take elements. So if k is greater than 0, that means I can actually still take some elements from the input array. Now, okay, this is also okay. Next condition is that in the set, this number should not be already taken. 10 should not be taken previously. So I'll check that 10 is present or not in the set. This is not present, so I can take this. So what is I have to do? I will store this in the distinct array, distinct set. Thus 10 is already taken, and k minus minus, because I have consumed one number. So suppose previously k is equal to 4. So after taking one element, how many numbers I can take after that? 3 elements only. So that's why I have to adjust this by k minus minus. Okay, and our answer array, I will store 10. Got it? Because they actually mentioned that what is the order they need? They need it in the descending order. Means 10, 9, 8 in this way. So got it? Next, I'll come to this element 9. Okay, k is still greater than 0. Yes, because k is still suppose 3 after taking one element. So this is still actually greater than 0. So I can take one element. So I'll check that this 9 is already taken or not. So how we can check that this is already present or not? So efficient approach to take one set. So in the set 9 is not present, so I can take this. So k minus minus. Now k will be 2. Okay, and this 9 will be stored into the answer, and this will be also stored into the set, because this number is present in the input answer array. Got it? Next I come to this number again 9. So how do you check? K greater than 0? Yes, k greater than 0. That means I can take element, but I have to check that this is already taken or not. So from the set distinct set, I can actually check that 9 is already present or not. Yes, 9 is present. So I can't take this. So I go to the next element 8. So you can just see the state that k is still 2, and our set is still 10, 9, and our answer array is still 10, 9. Now I come to element 8. So in the 8, what is check? First of all, check that can I actually take any element or not, new element. Yes, k greater than 0, because k is still 2, so I can take. So next is I have to check that this 8 is already taken or not. So how to check that? We will check in a distinct set this 8 is present or not. Yes, 8 is not present, so I can take this. So I'll store this into the answer, and this will be now decreased by 1, and this will be present in the distinct set now. Got it? Clear? Now go to the next element 7. 7, first of all, again k greater than 0. Yes, k is now 1 is greater than 0, so I can take element. So next is I have to check this 7 actually I can take or not. So what is the condition? From the distinct set, I will check that this is 7 is present or not. Yes, this is not present, so I can take this. So I'll store this in the answer, and also store in the set also. Clear? In the set also I will store that this is actually 7, and also this is stored into the answer vector also, and also decrease the k value is now 0. So suppose there is one more element, suppose 6. So I'll come to this 6, but I have to check that can I actually take any new element or not. So what is the condition? I have to check that k greater than 0 or not. Yes, this is false, because k is now 0, so we can't take any new elements now. And what are the numbers we have taken till now? This is all like maximized, because we have sorted on the descending order. So if I have to traverse from left to right, we'll get the maximum value first, right? So that's why I'll stop here. Got it? So our answer vector will be look like 10, 9, 8, 7. Clear? So what is how actually we can solve this? So first of all, sort the input array in descending order. sorry, what is the spelling? I got yeah, sorry, descending order. Okay, so first of all sort the input array in descending order. Got it? Now traverse the left to right, and to check that this whatever number currently I am checking. So to check that this number is already taken out, I need actually one set. So this set will contain only whatever the number actually I have taken in the answer variable, in the answer vector. And also I need actually one answer also, that actually vector of integer. Correct? So now actually I iterate the sorted array from left to right. So I'll check that what the number actually present. This k is greater than 0, and this set, if I try to find the current number, it should be it will return that this is not present, right? Then actually I will take this element into the answer, and also k minus minus, and also I will do the insert into the set, because set actually contain only the insert the current number I. Got it? This is clear. Now go to the code. So first of all sort the input array in reverse order, means from descending order. So I have to return one vector of integer for the answer to return in the order of whatever number I can take. So this will be vector of integer answer, and set of integer, this actually indicates the which number actually already taken. So variable name is taken, that's why. And now iterate the sorted array, okay, from left to right, because this ensures that this actually maximizes the sum. All right. So first of all, I'll check that the current number, whatever number actually I have, I'll check that this number actually present or not, like already taken or not. So if it is not taken, so then actually we can actually add this into the current in our answer vector. So if it is find of the current number I, if it is equal to taken.end, that indicates that this number is not present. So I'll check that can I take this current number or not. So if k, I can take this current number if k greater than 0, right? Then actually I can actually still have some capacity to add some element into the answer vector. So I will take this, I will actually insert this first into the set to ensure that this number actually is already taken into the answer vector, and also store the current number into the answer vector that actually I have to return, and also do the k minus minus, because this indicates that I have already consumed one element. So I don't have any like it's indicated that I have actually one less capacity, right? K minus minus. Else I'll break. When actually I'll break if our k is already 0. Else means when actually our k is already 0. Alright, that means we can't take actually any new elements in the answer vector. That time just you can actually break from the input array, sorry, from iteration, right? So ultimately return the answer. So what is time step for this? So to sort the input array, it will take, if the input array length is n, so it will take n log n. And here you can see that we are iterating the input array again. So again it will take big of n. Got it? So ultimately it will take time velocity of big of n log n. Correct? So I hope this is clear for you, and if you had any doubt, you will comment on that. And if you have any suggestion also, that also you can share. Thank you. Bye bye.